We're going to go over lesson 3, problem set. This was on powers of 10. As you can see here, each of your base numbers is a 10 with a different exponent. Most students get these correct, and even this one correct, but a lot of times they get these wrong because there's a multiplication problem there. Let's zoom in and look at these a little bit more closely. So this is 10 times 10. We know 10 times 10 is 100, so that's why it was 10 to the second power. Now this was 100 times 100. You might not know what 100 times 100 is as easy as you know what 10 times 10 is. But there's a shortcut. How many zeros do you see here in 10? In 10 times 10? 2. So it's 10 to the second power. How many zeros do you see here in 100 times 100? 2 and 2. You see 4 zeros, 10 to the fourth power. The number of zeros will tell you what your exponent will be. That only works for powers of 10. When we do exponents later in the year, you can't use that trick. But for powers of 10, it will work. 4 zeros, 10 to the fourth. 3 zeros, 10 to the third. 2 zeros, 10 to the second. So on and so forth. The last two both had 6 zeros, so they were both 10 to the sixth. Now if we look at the next section, you're multiplying and dividing by powers of 10, which is something very similar to what we did previously when we were moving our digits left or right. But instead of saying 9 times 10 to the third, it would say 9 times 1,000. But now they're just taking that 1,000 and writing it shorter. So 9 times 1,000, 9,000. 39 times 10 to the fourth, well 10 to the fourth is 10,000, so it's 390,000. 7,200 divided by 10 to the second, I want to get smaller. I want to go backwards 2 times, so it's 72. 7,200,000 divided by 10 to the third, I want to get smaller by 3 place values since my exponent is 3, so I back up 3 times and it's 7,200. Remember, even though you don't see decimal places on any of these numbers, there's always 1 at the end of the number. When you move to the second section over here, they actually had decimal places there. So all you had to do was either move the decimal right or left to make your numbers bigger if you were multiplying or smaller if you were dividing. And you can see, maybe I can zoom in a little bit more. I call them swoopies, how I'm swooping the decimal place. It was 4 and 25 thousandths times 10 to the third, so I took my decimal and I moved it 1, 2, 3 times. That's why it was 4,025. Every time I moved my decimal, however many times it was in the exponent. If you're missing these, you need to email me questions so that you can better understand them. And if you're missing a lot, you might want to go back to the homework side and review those. Alright, we're going to skip over to the patterns. You will have a test question like this on patterns. It's still multiplying and dividing by powers of 10. They just didn't tell you what they were doing. You had to figure that out on your own, which is what I did over here. So I saw that the numbers were getting larger each time. 300ths, then 3/10ths, they're getting larger. So I knew that was multiplication. They were moving 1 place value over, so I knew it was multiplying by 10. So I continued that pattern. 300ths, 3/10ths, 3, 30, 300, 3,000. Here I saw my numbers were getting smaller, so I knew that was division. But it was a little harder to figure out what they were dividing by because they weren't just moving over 1 place value, they were actually moving over 2. So they were dividing by 10 to the second or dividing by 100. So I had to continue that pattern by moving 2 times. So I had 650, then 6.5, then 65 thousandths. This one, you couldn't really use the beginning part to figure out the pattern. You had to use this part right here. 94 and 3/10ths, 9 and 43 hundredths. They divided, it got smaller just by 1 place value, so it was dividing by 10. So I continued to divide by 10 here. However, when I'm going this way to try to figure out these answers, I actually have to multiply by 10 going this way. So I took 94 3/10 to multiply by 10 to get 943. But if the pattern is still dividing by 10, because you read the pattern from left to right, it just had some blanks at the beginning of the pattern, so that's why you had to use the inverse operation or opposite operation to figure out what went at the beginning. Alright, the last two were times 10 and times 10 to the second, or times 100. You can see my answers there. The lines were a little small to fit all that in. Remember to look carefully, and if you missed any, then give me a shout through email and we'll go over it. We also have math meetings this week, so y'all could bring questions to your math meetings if email wasn't enough. We're going to go over a few more of these word problems. So Shawnee and Marion or Marlon missed the lesson on exponents, and Shawnee incorrectly writes 10 to the fifth is equal to 50 on her paper, and Marlon or Marion, whoever that person is, incorrectly writes 2.5 times 10 to the second is 2.500 on his paper. And so A and B asked us to explain their mistakes and also to say what they needed to do to correct it. So Shawnee thought she was supposed to multiply the base number by the exponent. She said 10 to the fifth was 50, so she just multiplied 10 times 5. That's not right. She should have multiplied the base number by itself 5 times. 10 times 10 times 10 times 10 times 10. That's 1, 2, 3, 4, 5 tenths, which is actually 100,000. You will notice 10 to the fifth, there are 5 tens, and there are also 5 zeros in your standard form. Marion thought the exponent just meant to put 2 zeros on the end of the number. If you look at what Marion did, 2.5 times 10 to the second, her place values didn't change at all. Her value did not change at all. All she did was put 2 zeros at the end. That is not what that exponent means. Okay, so they had to multiply by 100, which means it got larger by 2 place values. It says, but the value of her digits did not change, and I go on to tell her she could have moved her digits 2 places left, which is what I did down here, or she could have moved her decimal place 2 places right to get her answer. Either way, if you move digits left or decimal right, you still get 250. Remember, if you have questions, to email me, and if you missed a lot, you probably want to go and look at the homework side. We're not going to go over the homework side unless you have major issues that you email me about, but I will be looking at the homework sides of all your papers when you turn them in on your test days.